Hello, everyone. Full room. Thank you all for coming here today. Our next speaker will be Jeroen from Xebia. Just to get a bit of a show of hands going. Who here before this talk heard of RAG? Who here has used it? Well, okay. I think we've got a decent crowd for your upcoming talk. Please give it up for Jeroen.
Thanks, everyone. It's really, really great to be here together with all of you in this full room in the PSV Stadium, very unique location. And thanks for the show of hands, Rob. It's nice to see that so many people heard of RAG. And also, if you use RAG, we are going to learn together more about RAG. So that is very nice. So before I start, I want to introduce myself. I'm Jeroen Overschie. I'm a machine learning engineer at PyData. And what we do is we help companies bring machine learning applications into production. And more recently, I focused on generative AI and also RAG. So that said, first we want to figure out, okay, why should you even care about RAG? So if we take a timeline here of the last 5 years, and then we plot the time when the original RAG paper came out, which is in the beginning of 2020. Then what we also going to plot is the launch of ChatGPT at the end of 2022. And now we're actually interested if we take Google Trends and then we search for Retrieval Augmented Generation, then what happens if we plot it in this time frame? Then we can actually see that even though the paper came out a while ago, only Retrieval Augmented Generation got massive interest after ChatGPT launched. So it was really the pivotal moment of ChatGPT when Retrieval Augmented Generation also became very popular. So when we're wondering about why we should do RAG, maybe we can first look at the situation when we don't use RAG. So if we interact with the model without RAG, so we have, as a user, a question, and we want the large language model best as possible to answer our question. Then normally we get a response back, and we're gonna test this out actually. So we're gonna ask the large language model a question. What was the result for European Cup 2024 game Netherlands against Austria? So actually Austria should say England here, because the answer I took from the question when it says, what was the result for European Cup game Netherlands against England, which was yesterday. So the large language model gives us the following answer. European Cup 2024 has not taken place yet, so there's no result for the game between Netherlands and England. So it denies the fact that this game took place at all. So that is somewhat problematic. So why is this? So if we ask the same LLM, what is your knowledge cutoff? Then it is going to say, my knowledge cutoff is April 2023. And this is the reason why it cannot answer our initial question, is because the knowledge cutoff was way before all this recent information came into play. So what we can see is that when we normally interact with a large language model, the knowledge that it has internally is outdated. We can also not access internal company data, and we are also prone to hallucinations, because by lack of evidence, the large language model might come up with its own creative answers. So let's skip to a situation where we do use RAG. So when we're using RAG, we introduce another step where the user query is first going to be used to search inside documents that we defined or a database. And from those documents, we're going to retrieve the relevant piece of information and use them to then answer the user question. So we now have documents, but we can also employ some search engine that we're all familiar with. So now let's ask the same question again. What was the result of Netherlands against England? And now we can see we get actually the correct answer, 2-1, very painful memory, unfortunately. So what we can now see is that we introduced RAG, and we can now have up-to-date knowledge, and we can access internal company data. And we can also make our answers more factual, because we can exactly cite which source of information we based our answer upon, and then use them to create user trust. So this is very nice. So we can see that there are multiple benefits for using RAG, and it is useful, but so how does it actually work? So what we're going to do is we're going to understand RAG in different levels of difficulty. And the levels of difficulty we're going to look at are level 1, 2, 3, 4, starting with a basic RAG, going to hybrid search, then advanced data formats, and finishing with multimodal. So we're going to start our journey with the baby parrot and then progressing all the way to our nice, mature, and good-looking parrot. So let's start with basic RAG. So we saw our interaction that we had before, and we're going to split it up in two parts: document retrieval and answer generation. So we're going to zoom in on the first part, which is document retrieval. So on the right-hand side, we have some API where our request is coming in, and we have our documents laying around. So how do we retrieve the correct ones? So given that we have the question from a user, we want to get the right piece of information back. So what we're first going to do is we're going to take the question, and we actually want to convert that question into an embedding. So what is an embedding? So this is a drastically oversimplified explanation for what is an embedding. But here we can see in 2 dimensions, actually, some data points which are related to each other. So you can, for example, see that these words are more related to each other on the left top side than right bottom side. For example, man, women, teen are more related than words like king, queen. So that we actually want to do for entire sentences and paragraphs, such that we create an embedding for them, such that they are semantically related to each other when the points are close in space. So we create this vector, which in practice is much bigger than 2 dimensions. And using that vector, we can store that somewhere else. So we're going to also embed all of our documents. So we have embeddings for the question and embeddings for documents, and we're going to store them in one place, which is a vector database. And the vector database is really good in doing similarity search, often used cosine similarity search. And then using that vector database, we're going to retrieve the relevant documents and then send them back to our API. So that is nice. So we have a basic document retrieval step using vector search, which now we can use to generate the answer. So how does answer generation look like? Answer generation, we're going to introduce it in a really simple way, which is just we're going to use a prompt where we're going to instruct the LLM, you are an assistant for question answering tasks. Use the following pieces of retrieved context to answer the question. If you don't know the answer, just say that you don't know. And that last part is actually quite important, just to instruct the LLM, okay, don't come up with random stuff, hallucinate. And then we're going to insert the question and the context, and the answer is to be generated by the LLM. And this is one of the default prompts that LangChain advertised in their documentation, and it's also available on the LangChain hub. So we have our RAG system in place now, so let's give it a spin. And to give it a spin, actually, we need some documents. So I created a toy RAG system, so to speak, using the PyData 2024 schedule. So we take all the sessions from the PyData Eindhoven schedule and we embed them. So when we embedded the sessions, we can store them in a vector database, and then now we can query it. So maybe let's ask first a question. Which talks are related to sports? Return a bullet list. So then now it's going to go through our RAG system, and we're going to be returned a couple of talks. Here are the headings of the talks. And then using those talks, we're going to put all of them in the prompt, including the description and the abstract and the title. And then the LLM is to generate an answer for us. And here we can actually see it's listing 4 talks. Well, I double check in the schedule. There's indeed 3 talks. They're actually categorized as by sports, so they're definitely about sports. There's one other that I checked at the end. It's called How I Lost 1,000 Euros. And that is also somewhat related to sports, so I understand why the LLM returned it. So this is nice. So we built a RAG system to query our PyData Eindhoven 2024 schedule. But I hear everyone thinking how to better visualize this, because now this is more of a PowerPoint visualization, but how in practice do you visualize this? So we are looking for LLM monitoring platforms. So a couple of them are the following. So Phoenix is one, LangFuse, which is very nice open source monitoring tool, and also LangSmith, which is very closely coupled with LangChain, which is the tool that I used to create all these examples. So we're gonna use LangChain right now. LangSmith, sorry. So LangSmith looks like the following. So here we can see different runs that we did with our RAG system. And if we open one run, we can see, okay, what kind of interactions did we do with our model? So in a RAG system, then we have the retrieval step, and then later the generation step. So here we can see, okay, we retrieve some relevant documents, and then later we generate our answer. So this is really convenient, so we can double check exactly what went into the prompt of our model, which produced a certain output. So that is very nice. So we have our RAG system now, but we're actually wondering, can we get more detailed? So what do we mean with more detail? So we now embedded each session, and then a session text, it can be somewhat long. So what we actually experience is that we embed a large piece of text, but the embeddings can get saturated and lose meaning. So you have to imagine if you embed a very, very large piece of text, and then you do that for multiple text, then it's gonna lose its semantic meaning. So maybe we want to create smaller pieces of text, right? And also what we cannot do is we cannot do very precise citations, because if we divide it up in smaller pieces of text and we find exactly those, we can say, okay, this is what I used to generate my answer. And also what we can see is if we have a very large context, of course, this comes also with a higher cost. So this is not ideal. So what we're gonna do is we're gonna divide up the text in smaller pieces and then embed those smaller pieces. And this is chunking. So we're gonna look at chunking. So let's do a chunking 101. So we're gonna take the beginning of one talk, an abstract of a session, and then we're gonna chunk it. So one strategy is one very naive strategy is just after a fixed amount of 25 characters, split the text. But you can see here actually that in the third word, experimentation, it's split in the middle of the word. And also going to the next paragraph, it says subtle effects and then conv, and that is also one chunk. And that is very much not ideal when we're creating the embeddings, so we want to do something else. So we can use the recursive character splitter instead, and that actually is a bit smarter than the character splitter. It looks at, okay, what kind of paragraph breaks, new lines exist in the text. You can, for example, see the paragraph is split by 2 new lines. And it's going to take that into account when creating the chunks. So here you can see already we have much nicer chunks where the words are at least in one piece. But I especially want to emphasize these methods are two examples that I give, and LangChain is full of text splitters. The internet is full of chunking methods, and there's like studies on its own basically for that. So we're gonna now take our RAG system and test it to do a similarity search. So we can see, can we get more fine detail information out of it? So we're gonna do a search for this sentence, a methodology for comparing 2 versions of a web page or app against each other to determine which one performs better. So maybe some of you already come up with, what is this? What is this word we're looking for? It is A/B testing. So this is a different way of describing A/B testing, and here we just do this query, we get an output with all sort of small segments of a text, which actually comes from this talk, which is very nice because now we can actually more accurately do citations, which is very often a demand which you see in when using a RAG system is you want to create some evidence for your answer. So that is nice. So we return to our document retrieval step and we add something else, which is the chunk text step. So this is great. We still wonder, does our RAG system catch all cases? So we actually need to investigate a bit further what cases does our RAG system handle well and which doesn't. So we actually go back to our Langsmith UI and we do a query. We do a quite naive, stupid query. What is the talk starting with maximizing about? And actually we get an answer. The talk starting with maximizing is about less common but noteworthy features of scikit-learn. And actually that is Vincent's talk, which is after mine. So our RAG system gave an incorrect answer because the talk that we are looking for, it starts with maximizing in the title, because that's what we ask. So this is pretty weird. So why is our LLM giving such a wrong answer? That is because it just cannot give the right answer if the right context is not there. So the documents it retrieved, they don't contain this talk. So how can we fix this? And to fix this, we need to go to level 2. So we go to level 2, which is hybrid search. So let's continue with this example where we had incorrect context to get the right talk. So actually, maybe we can use different search algorithms to fix this. So now we only use vector search, but there are other algorithms which are, for example, more full text search, sparse search, keyword search. You can use a lot of different terms for that, such as TF-IDF and BM25. BM25 we can consider an improved version of the former. So we're gonna use that and then actually incorporate it in our retrieval step. So we're gonna add some stuff. So here, besides embedding the user question, we're now also going to do a keyword search. So we're gonna take the session title, abstract, and description, put them also in a database, and then use something called reciprocal rank fusion to combine both vector search and our keyword search. And so how does reciprocal rank fusion work? So if we have two methods of search, then we can actually take the ranking of both and then combine them into one. So this is very nice, and there's actually a vector database which supports that hybrid search out of the box, which is a Milvus, which is open source. So we're going to use Milvus to improve our RAG system with hybrid search. So this was the case before hybrid search, where the correct document was not even in the context, and with hybrid search we can actually see, okay, it ranks number 4 in our result, and even if it doesn't come up in the first place, rank number 4 is enough, because now the correct context is in, and we can actually see we can get the correct answer now. So our RAG system is looking good. So we can answer also these type of questions. So that is very nice. But actually, I want to take you along in how did I even load in the PyData schedule. So if I have the PyData schedule, and then you can go to the website, and there's actually a nice button where you can just download the JSON. So it was not very advanced web scraping, but I can just get the JSON like that. And if all data that you encountered were structured like that, that would be great. But that is unfortunately not the case. You all work in real-world cases where you have to deal with other data formats. Maybe you have to scrape a web page, and different web pages come with different formats, and you have to figure out where's the content in, which CSS class is it in. Maybe your customer asks to do RAG with Word documents, or maybe even the toughest, a PDF. So PDF can be of any format, and it can be a scan, it can be an image, it can be some native text, it can be graphs, and it can be any layout. So this is super tough. So we need to go to level 3. So level 3, advanced data formats. So now let's take some PDFs as an example that we're gonna use and try to parse into our RAG system. So I like SpaceX, so let's take the Falcon's user guide in case you happen to own a Falcon 9 rocket. We're also gonna take some NASA document, which is a PowerPoint, so that's a bit messy, so I just throw that in to create a bit of difficulty there. And we're also gonna do a one-pager where we have an overview of the Falcon 9 costs. So how can we parse these PDFs? Well, LangChain comes up with some nice parsers out of the box, of which one of them is the PyPDF loader. And so we're gonna use PyPDF to parse these PDFs. So yeah, let's use that, and we're gonna parse them and get raw text. So here we get the raw text from the documents, and that's very nice. And we can see actually, yeah, some are quite well formatted, and some, okay, well, maybe this is somewhat messy, but we have at least the raw text extracted from the PDF. So now we have to go back to our document retrieval step and throw in another step, which is document to text. And then now we can also parse PDFs. So that is nice. So we're gonna ask our RAG system a question now. What is the price for Falcon 9 rocket launch with a standard payment plan? Because that is what many people are curious about. And here it says, okay, the price for Falcon 9 rocket launch with standard payment plan is 69.75 million, which is actually correct because I checked in the PDF, and there indeed it says it's this amount. So that is nice, but let's actually ask another question. What is the payload in carrying with a Falcon 9 rocket to Mars? And here actually our RAG system is saying 8,300 kilograms. But I check in the PDF, it's actually 4,020 kilograms. So now you end up taking 4,000 kilograms too much payload to Mars, which is quite inconvenient. So let's see, let's debug this a little bit. So what happened? So we open up Langsmith UI and we go to our generation step, and we're gonna inspect the prompt that we sent to the LLM. So this is the prompt. It looks pretty messy, but especially this text is the important one because this was a table that we saw with the correct information in it. And you can see because of the ordering of the information, our language model, it got confused. It got confused and it gave us the wrong answer. So that is pretty challenging. So let's see what we can do. So if we have this PDF with the table, here we can see the table in green. So now we actually came up to the point where just parsing only the text is not enough. So maybe we need to give it a separate treatment. So we can, for example, use a computer vision model. One open source option out there is table transformers from Microsoft. And we actually want to get our table in a native format. So when we have it in a native format, we can put our table as markdown in the context. So by this point, we need to recognize that there's a table in the PDF, put it in markdown in the prompt, and then actually our LLM can very much well work with markdown so we get the correct answer. But by this time, I actually do have to make a confession, which is that the model that we used is GPT 3.5 Turbo. And by now, there's a lot of newer models out there. So what about the newer models? So we go to the final level, which is multimodal. So with multimodal, we're gonna take the prompt that we had before, and we're actually gonna upgrade to GPT 4.0. So GPT 4.0 was a model that was launched in May this year, and it can reason across audio, images, and even video. And that is very exciting, so maybe it can help us with this use case. So what we can actually do is we can insert the PDF, but as an image, right into the context. So this is assuming that we can retrieve the right page of PDF using a retrieval step, and then insert the correct page or pages into the context, because GPT-4o can work with images. And actually now on the top we can see, okay, we also get the correct answer. But I also want to inspect, okay, what is the cost now? Because we can see we use 142,000 prompt tokens, which is $71, which, yeah, we use all those tokens to get the correct answer. But if we compare that to our old approach, which is GPT 3.5, we use 0.000369 $, which is a small increase of 2,000 times. So that is quite heavy. So given that we can use these nice multimodal models, we have to take into account the cost, but it can bring us to another level of leveraging also images or even audio and video. So that was very nice. That was multimodal, the final level, and we saw 4 levels now. So let's now actually conclude on the 4 levels that we saw during our entire journey to see what did we see and learn. So for basic RAG, we saw we do RAG with a retrieval step, then augmentation and generation, and we do that using the different components. Like we need a data collection and parsing step. We can do chunking, embedding. We can use a vector database and a large language model. And then we use vector search, and maybe we have to chunk our text as well. Then we continue to level 2, and then we combine vector search and keyword search with reciprocal rank fusion. And we can use algorithms like TF-IDF and BM25. Then with more advanced data formats, for example, HTML, Word, but especially PDF, we get extra challenges. So now we can do native text parsing, but also we encounter images, or maybe you have a scan of a page, and this threatens us to get jumbled text which we put into prompt, which causes our LLM to convincingly give a wrong answer. We can also see there's tables that we want to give a special treatment, maybe using computer vision, or we convert it to Markdown. Then coming to our final level, where we can leverage the latest of the models, what the models have to offer us, to use multimodal models for audio, image, and even video, and we could put images in our prompt, which is very powerful, but we have to be aware of the cost. So given that we saw all 4 levels now, and we understand how RAG works, when we can use it, and when it is most powerful, then for me only one question remains, and that is the question, what is your level? Thank you.
Thanks so much, Jeroen. I think there will be plenty of questions, so I'm afraid we can't go through all of them, but we will have time for a few. You will be around at Xabia's sponsor stand, if I understand correctly, so you can always go up there on the 3rd floor and ask Jeroen more questions. So without further ado, questions from the room. I'll remind you, a question is 1 or 2 sentences and ends with a question mark. Let's start over here.
Hi, thank you so much for your talk. I have maybe an ideology question, because I saw that there is a pipeline, and every time you're trying to evaluate, you're going manually through each part of the pipeline to understand where the process goes wrong, which I can imagine very time-consuming. Do you see that being somehow automated, and if so, how?
Yeah. That is a very good question. Actually, something that I would have desired to put in the talk, also about feedback and evaluation systems, but which is just not enough time for. Because actually, I think that if you are building a RAG system on a larger scale, you need proper evaluation systems in place. So you can tweak your RAG system and get some quantitative feeling of, okay, what is happening with my system. There, you need a elaborate test data set to do these things. So this is stuff that we do at our customers as well.
So the data set is the answer.
like what I would say is, okay, you will need to craft a representative and meaningful data set to evaluate against. And there's a whole world of computing metrics on top of that. So I think that is nice material for another session somewhere in PyData.
Thanks for the presentation, a very cool presentation. I had a question about the chunking. In your example, you show an example that starts with 25 characters. I was quite a bit surprised, like that seems extremely short, but that might be just for the illustrative purpose of the presentation. But I do wonder, like, do you have some rules of thumbs and learnings that like help to decide what is a good chunking size? And of course, it's going to be a bit dependent on the use case, but like, what rule of thumbs do you use?
Yeah, my answer is going to be a little bit disappointing because it's like super dependent on what you encounter. So this 25 characters was indeed for illustrative purposes because even the defaults that LangChain advertises are way more. So yeah, the chunk size, I think it should be a conversation also even with your business user going through the structure of the document, seeing, okay, how is it separated in different sections and paragraphs to really reason about, okay, what kind of chunk can we capture with which has meaning, which has most meaning. So there, I think it should be on the one hand side also explorative, so you test different chunk sizes and overlaps. And yeah, it should also be like a feeling where you feel, okay, these paragraphs I can best chunk. So I wish to have give you like a number, but that's not possible.
Hi, I'm over here. Thanks for your talk. As a person who has worked with LangChain to build something not so trivial, I'm wondering, what are your experiences with LangChain? Do you like it so far, and would you recommend for using it in production? Because personally, I find it to be a bit over-engineered, so I'm always hesitant to use it for that reason. Thank you.
Yeah. That's a question that actually we talk about also frequently with colleagues, where what I personally feel is that LangChain does very well get you started, and you can swap around different components because it has these abstractions. And maybe by the time that you progress in your journey to production, it can get in the way. Also, I feel is that LangChain does some changes, or maybe it breaks your code, or you want to be closer to the native APIs that all the providers give you. So yeah, my experience would be is it very much gets you started, and then for production, if you really want to run something very stable, then maybe you want to peel off some abstraction layers and just stick closer to the core, get some more stability there. Yeah.
We have the same experience.
Okay, great.
I had a question, like how did you insert, like, first of all, images in like level 4 of the racks? Like, did you use another splitter? And like my second question was like, your vector DB also has to be multimodal, right? For the level 4, it's not just your model. So I have experience with Chroma DB, like did you use something else, or it's just the model that needs to be multimodal, right?
Yeah, so the multimodal step, so it isn't by accident level 4, because also what I showed was just, okay, how can we put images in the prompt and answer questions about a table, for example, that's inside such an image. But indeed, like you're saying, okay, there is a whole other step that you need to take into account in retrieving the correct images, for example, that we then use. So yeah, indeed, a vector database, if the similarity search, all it cares about is a vector, you can embed or vectorize also images, right? So there, in that way, a vector database can handle these things. But there's a whole lot of options there. So do you embed some text that describes the image? For example, you have an image and you have some alt text or a caption. Is that enough? Or do you want to create image embeddings? So that is indeed what you have to take into account also when doing these multimodal operations. Yeah. Thanks.
Jeroen, again, thank you very much for your presentation. And on behalf of the organizing committee, the very exclusive PyData. Thank you.
Thanks. Thanks, Rob.